Hi, good morning. Welcome to my program. I'm Dinesh Vijayavardhana. Today we are going to continue with my last topic, which is wave. Last week we discussed about the wave. What is the meaning of the wave, and what are the properties, and how it behaves, and also what is uh, mechanical terms associated with the wave: amplitude, the period, and the wavelength, and the frequency, etc. So today we're going to refresh the past knowledge, and then continue to discuss the characteristics of the wave. So wave, as we mentioned last time, the wave is a disturbance travel through a medium a disturbance travel through a medium or a space, and that is what is space, and that is what is called so as we mentioned, the medium is it is usually a fluid. So fluid, when you consider fluids, it will be either air, gas, or water, or it could be empty, which is like space, which does not have anything, a vacuum. So that's the wave, and now we're going to discuss what are the characteristics of a wave. So characteristics of a wave, basically, um, wave, like if you draw the wave, so if you draw the wave like even without the graph, let's say, so that's like a wave, and that travels. Okay, don't worry about the properties or where it sits on the graph. So this is just a general wave, and so that's the velocity, that's travel, the speed. So at one point it will be here, and another point it will be here, and so same peak travels through, and it's just continues. So first characteristics of a wave is the energy transmit. So energy transmission, that is what it does. So if you consider a sound wave, it transmit sound from one point to another. Energy transfer from one point to another. So in this case, position A or to position B here, or position C. So that's what is the first characteristics of the wave. The second one is that when the energy is transmitted, there is no substance. No substance is transmitted. So basically, it is just a wave, a sound wave, or a radioactive wave, but it would not transmit, would not transmit any substance. So substance means um, basic a mass. So um, for example, when the sound wave travels, it only transmit the um, the energy. So energy, it will be E, which is usually calculated by joules or kilojoules or megajoules. So that's the energy. Um, but in that particular substance, let's say example, a sound wave, or let's say a wave in the sea. So that's the wave in the sea, and that travels and that transmit the energy from one point to another point, but there's no weight transmitted, no mass taken from this point to another. What it happens is that it takes on the medium. So this is the medium, this is the water medium. It takes the peak of the wave, and it travels on the medium. So it just pushes one particle to another. So it push this particle, and then another moment it just push this particular particle forward. So it just travels. It does not mean this particular mass is taken to here. No, it does not take the mass to it. It just push particle to another. So there's a particle here that pushes the next particle. So if you draw it bigger, the wave, there's a particle here and there's a particle here. There's particles here and there's particles here. These particles pushes against it. So, and when this particle pushes and the other particle moves, the other particle pushes, the next particle moves. So it just pushes, the next one moves, pushes. So that's what it does. That's why it's only transmit energy, no mass, zero mass. Mass is zero. No mass is transmitted through the no mass is transmitted through the medium. And the next term, now let's discuss the next thing, the third characteristics, which is so third characteristic would be energy, the energy that transmit, the wave that travel on a medium is, this particular medium can be material medium. So this particular medium can be either material medium or non-material medium. So non-material medium means let's start with the material medium. So wave, in order to wave to be traveled, there should be a medium or space. But if you consider medium, that will be material or non-material. Material medium is it could be either like water or air or even gas. So that's a material medium. So a material medium that travels through a wave that travels through a material medium is falls into this category. A wave can travel either material medium or non-material medium. So materials are water, air or gas or any etc. And one example wave type that travels through this sort of material medium is sound wave. If it goes into this category, it will have to be non-material medium. So non-material medium would be like a space. So for example, electromagnetic waves. So electromagnetic waves does not need material to be traveled. That's why even in space, like even there's no atmosphere, we can still feel the gravitation, the electromagnetic fields of planets or or stars. So, so the greatest example for that um, is the space, um, like the moon electromagnetic or Earth and moon. And then there could be other waves like X-rays, which does not need any material medium for it, and it just travels, and it's very harmful to X-rays, because it can travel through any type of medium, um, or it could be um, like radio waves. So the radio waves that we listen to, like FM frequency modulation or AM, any of these frequencies like 101 megahertz FM, so that sort of wave can travel through non-material medium. So even if you are in a space, you can still hear the radio waves. So that's why it says non-material medium. So this is what we have today on our lesson. I'll see you next time with another topic, maybe another next level of the sound wave, or we will go into mechanical waves and other type of waves in my next session. Thank you.